So in this question says that what is the greatest possible speed at which a girl can walk 95 meter and 175 meter in exact number of minutes? Well, the question here is the greatest speed, and the greatest speed, let's figure out. First of all, what I'll do, let's say I will take the first journey to be this of how much? 95 meter, and the other distance that she has to cover, let's say this one. So this is 171 meter, and the first one was how much? 95 meter. So what does it mean when they say that it is in greatest speed? So you know that the speed is what? The speed is what? Distance traveled per unit time, and the unit time is the minute. So you can, in this case, so what you can see from here that whatever the distance covering, it should be the exact divisor. It should be the exact divisor of this. The distance covered per minute should be exact divisor of 95, and similarly it should be the exact divisor of the other number, which is 171. So clearly we are going to find the HCF of these two. So I'm going to use the prime factorization method. Let's say if I factorize 95 is what divisible by 5, 19 times, right? And 19 one time. And if I factorize the other number, that is 171 by 7 plus 2, 9 is divisible by 3. So that's why I am divided by 3 here. So you can figure out that 3, 5 times 15, 3, 7 times 21. So it is still divisible by 3. So I'll continue dividing by 3 again. And that comes out to be 19 and 19 one times. So if I write down the prime factorization of 95, it comes out to be 5 into 19. And for the other, which is 171, it is 3 square into 19. So the highest common factor, as you can see, 19 and 3 and 2, 5 does not have a common factor. So only 19. So we'll say that the HCF here is what? 19. Well, this is an MCQ, so no need to write down the statement. We'll simply say that 19 minute per 90 meter per minute. So that's how we'll do. Let's come to the next. In this question, it says a circular field has a circumference of 360 kilometer and three cyclists start together and can cycle 48, 60 and 72 kilometer in a day, right? In a day, it is around the field. The question is when they will meet. So first what we'll do, let's say this be the circular path. And if I take these as being the cyclist here, say the first cyclist here is covering 48 kilometer, right? It's not covering the whole journey, right? So know that it's not covering the whole journey or the whole circumference. I'll say that in one day it can cover, let's say starting from here, it goes till here only, right? And similarly, the second cyclist, as you can see that the second cyclist, as per the question, is again moving, but in one day it can not cover the whole journey. It can cover up to certain distance, and let's say it has covered up to here, right? So what you need to figure out here that the answer for this is not the LCM of these three numbers, as you do, most of you do this in the examination. So what we need to figure out is the distance covered by each cyclist. Time taken by the cyclist to cover this whole circumference. So let's say the number of days taken by the first cyclist in to come to the starting point, that is this circumference, what do you say, starting point, say in X number of days, the other taking Y number of days, and the third taking Z number of days. So the HCF of these, and the question is when, right? The when is what? Is the time. So we'll be finding the time taken by each cyclist to come to the starting point, and we'll find the LCM of this. So let's begin with finding the time taken by the first cyclist. I take the TA stand for the first cyclist. Time is equal to what? Distance over speed. And the distance is what? Distance is 360. That is the circumference of the circle, which is 360 divided by time is 48. Now this much day it will take. Now since we are getting in fraction, that's why I'm converting this day in hours by multiplying with 24. So this much hours. Now I can see it can be reduced further. This is divisible, right? So 360 divided by 48 comes out to be 7.5. So what I should do is to divide this by 2, right? First I divided 48 by 2 and then by this, which is 180. So the time taken by the first cyclist in hours is 480. Now similarly, I'll get the time taken by the second cyclist, say TB. The distance covered is 360 divided by, the circumference is 360, right? The circumference is 360 and the distance covered in 1 hour, one day is 60. So the number of days, right? This is what? The number of days. Since we calculated the previous one in hours, we'll also calculate in hours only. So if I divide, this is divisible by 6 times and this is 72 hours. So 24 into 6. So 24 into 6 is how much? 144. So this is 144 in hours. And similarly, if I take the time taken by the third one, say TC, to complete one revolution is what's 360 divided by 72 hours. As you know, the journey is of one complete circle is 360 kilometer and covering 72 kilometer per day. It will take how many days to travel? So I should convert in hours. So this is 72. Clearly it is divisible by 5. So it comes out to be 120 hours. Now once we have get this, what we are going to find out is the HCF of these numbers, that is 180, 144 and 120. So you will be using the prime factorization method to find the HCF. Let's say I do on the other side. This is for, I'll get for 180, the prime factorization is what? 2, 90 times 2, 45 times 3, 15 times 3, 5 times and 5 one time. For the other, which is 144, is going to be what? With 2 it is 72 times 2, 36 times 2, 18 times 2, 9 times 3, 3 times and 3 one time. And the last is 120. Yes, 120 prime factorization is what? 2, 60 times 2, 30 times 2, 15, 3, 5 and 5 one time. Now check what we know about the prime factorization is clear and we have to find its LCM. So we'll be using this space. So the first I can see that 180 is prime factorization is what? 2 raised to the power 2 and 3 raised to the power 2 and 5 one times. For the next, which is 144, I can see it is 2 raised to the power how many? 4. 2 raised to the power 4 and into 3 square. There's no 5. For 120, it's how much? It's 2 raised to the power 3 and into 3 into 5. Now for finding the highest factor, I can see that the so, 2 raised to the power 4 has the highest power of 2, and for 3 it is 3 square as the highest power, and I can see that the 5 is only 1 times anywhere. So I can see that the LCM here, this is LCM. LCM is going to be what? 2 raised to the power 4 into 3 raised to the power 2 into 5. So 2 raised to the power 4 is 16. 16 into 5 is how much? 80. 80 and 3 square is 9. Right. So we'll do 9 into 80, that is 720. 720 hours. But since we have to get the answer in day, as you can see, the question was in days. So that divided by 24. So if I divide it by 24, I'm getting how much? 30 days. So the answer for this, they will meet again after 30 days. That should be the final working.